Good morning, ladies and gentlemen. Welcome to our small lesson on, I believe it is a Tuesday, March 31st, 2020. Since it is a Tuesday, you can tell that I am tastefully dressed in my Taco Tuesday shirt, but this is going to be our first small lesson for these online programs. Before we start, one thing I did want to bring up is when I sent out my email to everybody yesterday, I got a whole bunch of responses back saying that, oh, this email is not valid, this email is not valid. So, ladies and gentlemen, for you students or parents who are watching, if you're getting these messages and you're getting to see this video, but you know of a friend or another student that's not, send them the link. Because we don't want school to start again with some people on the same page and other people having no idea that these videos existed at all. But, as you can see, our lesson today is going to be I, the imaginary number. It's a lesson that all my students should already know, but I wanted to cover it again since it's a first lesson. But, if we are now going on this, we can see that, let's travel back in time, a simpler time, when we had school. But first and foremost, I, as you can see, is equal to the square root of -1. Now you might ask, why is I equal to the square root of -1? Well, ladies and gentlemen, one thing I can tell you is that you cannot take the square root of a negative number. Like if I had something like the square root of a -25, and you plug that into a calculator, you would get something that would say error. It would not work because your calculator doesn't know what to do when it has a negative square root or a negative underneath the square root. But we want to say that I is a square root of a -1 because 1 is the most common, easiest number to do this with. Also might have some people ask saying, hey, why are we doing square roots of negative numbers in the first place? Well, math works because this works. Now, if we have something that's I squared, we can see that as I squared is the same thing as I times I, right? Well, I times I, and this is simply the best that I can do, I times I, well, when you multiply variables and numbers, you add exponents. What's 1 plus 1? 2. But we already know that I is the square root of -1. Well, that's square root of -1 times square root of -1. Now, if you've got two of the same thing, it's a square. So that's the square root of -1 squared. And what happens with a square root and a square? Boys and girls, you know the answer to that. They cancel each other out. So that is just -1. I squared is -1. Now moving on, we have I cubed. I'm going to see how much can I still get on this page. All right. Because, ladies and gentlemen, I hope you do forget my lack of professionalism. I'm doing the best I can. But I cubed. Well, didn't we just say when you multiply things you add exponents? Well, what is 1 plus 2? Well, 1, because if you have an exponent of 1, you don't technically have to write it. 1 plus 2 gives me 3. Well, we already know that I, as it says up there on the screen, is square root of -1. So I'm just going to keep that as an I. Well, we just said what I squared was. That's -1. So what's I times a -1? Well, that's a -I. Now, for this last one, we divide to the fourth. Give you about 5 seconds to think what we're going to do here, so if you want to pause the video, pause the video. And I am actually going to start my timer now. I'm going to try to get this video done in less than 10 minutes. If it's a little over, a little under, please forgive me. Still trying to get my flow going on this. But I to the fourth, under the same premise, I can add exponents. And my eraser, handy dandy eraser, well, if I squared is just I times I to the fourth, and I am going to put that there as a -1, I to the fourth, that's just I squared times I squared. What's I squared again? It's -1. But that means it's -1 times -1. And what's -1 times -1? +1. Negatives cancel out. And so that covers really our main things about imaginary numbers. Now, Mr. K, Mr. Kreitlein, what if we have I to the fifth? Well, I to the fifth is just the same thing as I. It turns out the i's go in a pattern. With that pattern, after you go past the fourth, they just revert. So I to the fifth is just I. I to the sixth is just I squared. So on and so forth. I think I'm gonna have to go rescue a cat in a moment because we have a little girl who's just a little cat who's just climbing inside of a chair. But I might bring her onto the screen later. But anyways, if you are one of my students, you know what happens next when you get to next page. I'm gonna check for understanding. Now I'm gonna handle these a little bit different. Because a check for understanding online class, I'm gonna give you about 5 seconds just to pause it, try to figure out what the answer to the problem is, and then we'll move on. But it says, which of the following is not a complex number? Meaning, which of these does not have an I? You want to find the answer that does not have an I. You have 4i to the third, 4i minus 4i, square root of -9, and I squared times 2i squared. Now, I've given enough time. The answer for this one is D. I squared times 2i squared. That one's going to be 2i to the fourth power. And what did we say I to the fourth power was? 1. I times 1, or 2 times 1, just 2. All right, moving on. Complex numbers. Admittedly, we did a little bit of this already, but remember that any complex number has to be written in the form of A plus BI. Now, admittedly, that can be written as, that's the same thing as BI plus A. As we see here, 3i minus 10 is a complex number. That's just 3i minus 10. B is your 3, or 3 is your B, and your A is just a minus 10. Pretty simple, pretty direct, pretty straightforward. Now I want us to take a moment and decipher this complex number. Now if this is the way, I want to get this out of the way, put it at the very bottom. I don't know if you can even see that, but once again, we're all learning here, so who knows what's happening. We want to decipher this complex number. Square root of 81, minus the square root of a -144. I'll let you know right now, this is a complex number. You have a real and an imaginary part, which is why it's complex. All you guys can do the square root of 81. What two numbers multiply together to give you 81? 9. So, but if I have the square root of 144, I can't take the square root of a negative number. So I want to break this down into a positive 144 and the square root of -1. We know what the square root of -1 is. That's an I. What's the square root of 144? It's 12. So this is 9 minus 12i. Because this comes down to be the 9, that comes down to be the 12i. I wish I had a stand or something that I could just put this on. One of the things that we as teachers really miss, writing on whiteboards. Really miss writing on a good old whiteboard. But if you've been in my class, you know I have a very tiny whiteboard, so not really anything's changed. Moving on, check for understanding. Now this is a blitz. Once again, I'm going to pause the video, see what you can write these down as. Or see, that's a very bad sentence, see what these can be written as their complex forms. Remember, a plus bi. Now for this first one, negative 200i minus the square root of 4. That's pretty simple. Square root of 4 is 2, and then you could just move the minus 200i to the back. You have your a plus bi, just your plus is now a minus. Doesn't change anything. Then, I've got 20 plus the square root of a negative 49. Well, my a is already established, but that square root of 49, or square root of negative 49, I'm just going to rewrite that as 20 plus the square root of negative 49. I'm going to rewrite that as 20 plus square root of 49, I am skipping a step. Instead of writing that square root of negative 1, I'm just writing an I, since that's what I'm going to do anyways. Then that simply becomes 20 plus 7i. I'm already at 11 minutes, so this might be my last part. I might have a follow-up video tomorrow on this. But let's finish up. Square root of negative 169 plus the square root of 9. You know that square root of negative 169 is going to be the imaginary part. So I'm going to write that in the back. I have the square root of 9 plus a square root of negative 169. Square root of 9, obviously that's 3, plus square root of 169, I. Well, what's square root of 169? 13. So, square root of 9 plus the square root of 169 is the same thing as 3 plus 13i. Final part is actually my most fun. If you see it on the board there, I'm wondering if I can actually screen pointer options. Oh my goodness, I can write on the pen here. I'm just going to write on the board. Or I'm going to write on the screen, doesn't matter. I'm a teacher, I can do what I want. So, I'm actually going to, my mouse disappeared. There it is, found it again. Screen, I am going to write in pen, and I'm going to have the pointer options be color, be black. So, doing the same thing here, I know that, and please forgive me, I ran out of room here, so I'm going to write up there. It's going to be 1 plus the square root of 45 times I. Well, 45 doesn't break down evenly. So if you wanted to stop here, I would accept that as an answer because it is a true statement. However, you can break down 45 into smaller square roots, which will be the final part of our lesson. So the 1 in front does not change. But let's break down 45 into a perfect square. Well, what divides 45 but is a perfect square? You know your perfect squares are 1, 4, 9, 16, 25, 36, so on and so forth. Well, the only one of those that divides 45, besides 1, is 9. Now, what's 45 divided by 9? It's 5. Well, 45 divided by 9. It's 5, Mr. K. Good job, class. So I can say that's the square root of 9 times the square root of 5, I. And I do apologize, this is very sloppy. But this is us wrapping it up. So I have 1 plus square root of 9 is 3. Oh, I think I hear a kitty cat. I might have a co-star coming up here. Yes, Nazgul, come up here. I have a cat named Nazgul. I have 2 cats, one named Nazgul, one named Minerva, and Nazgul's being very vocal. Square root of 5, there's nothing you can do, so I'm just going to leave it that as square root of 5 times I. Okay, come here, mister. And this is where we're going to end the lesson for today. Now tomorrow, we're going to talk about adding, subtracting, and multiplying complex numbers. Look at the camera, Nazgul. You're now the star of the show. Come here. Kisses. I love this cat. I love this cat more than some people. But, I'm going to put it down. But, yes. Now, if you have any questions about what we did today, about how we identify a complex number, or how we deal with imaginary numbers about that I, leave a comment. Visit the website that you can find in the description of the channel. It's kreitlinemath.weebly.com. You can go there, you can look at materials, or you can send me a message. But definitely, leave a comment if you have any questions, or if there's something that I need to go over again. Leave a comment of things that you want to see done on the channel. I hate to sound like a normal YouTube streamer. Leave a like, subscribe, leave a comment, whatever. But once again, students, parents, whoever's watching this, stay safe during these times. If you need to go out shopping for groceries, obviously that's important, but don't do dumb things right now. Stay at home. But once again, if you know somebody who should be watching these and it's not, send them a text message. Say, hey, Mr. K's got a video channel now on YouTube, and that he's leaving lessons, because the school is expecting us to do these things now. But once again, ladies and gentlemen, stay safe. Have a good day. And